This video will be dealing with simplifying complex fractions. Complex fractions are fractions within a fraction. For instance, the one over here, 1 over x over 2 over 3 plus y. It's important to understand the terminology used. The numerator is 1 over x. The denominator would be 2 over 3 plus y. But in each numerator and each denominator, there is still a numerator and a denominator. So it can get confusing saying the numerator of the numerator, in this case, which would be 1, or the numerator of the denominator, which is 2 in this particular situation. So a lot of times you'll hear the numerator on top for the 1 or the numerator on the bottom for the 2, with top and bottom referring to the primary numerator and the primary denominator, and then the secondaries being referred to as numerator and denominator. And that's normal, that's acceptable, people do it all the time. So when the phraseology is being used, you want to know what we're talking about. The numerator, it would be the top of the main fraction, 1 over x, and the denominator would be the bottom of the main fraction, 2 over 3 plus y. But if I wanted to talk about something more specific, I could say the denominator on top to refer to the x, or the denominator on the bottom to refer to 3 plus y. The numerator on top is 1, the numerator on the bottom is 2, so on and so forth. Okay? Now, simplifying a complex fraction, there's two methods available to you. The first method, you get the numerator to be over one denominator. Then you get the denominator to be over one denominator. Then you multiply by the reciprocal. And here's what that looks like in practice. For instance, if we had the complex fraction 5 over x plus 2 over 3 over 3 over x plus 2 minus 4 over x, we would want to get the numerator to be over one denominator. So when I say that, then that means I'm talking about just this part, focusing on just that. And I treat it like a simple addition of rational expressions. I would need to get a common denominator. In this case, it's going to be a 3x. So I go ahead and I put that down right away. I needed to multiply x times 3, so I need to multiply 5 times 3, and I get 15. I need to multiply 2 by x, 3 by x, so I need to multiply 2 by x. So I get 15 plus 2x for the numerator up there. Then I do the same thing to the denominator down here. I get my common denominator, which would be x times x plus 2. Then I get my numerator. I had to multiply x plus 2 times x, so I need to multiply 3 by x. And I need to multiply x times x plus 2, so I need to multiply the 4 times x plus 2. Once I have the numerator over one denominator, like this, and the denominator over one denominator, like that, then first thing I want to do is clean it up, make it look better. So I distribute the negative 4 on the numerator and the bottom, combine like terms, make sure everything's in descending order, and I can leave the factored part down there factored because it's much easier to work with factors anyway. Now, what I do at this point, I got the numerator over one denominator. I got the denominator over one denominator. What I do now is I realize that a fraction is division. Divisions are fractions, fractions are division. They're the same thing. The bar going across the middle there is called a divisor bar. So what I want to do is I want to turn that complex fraction into a division problem, which makes it 2x plus 15 over 3x divided by negative x minus 8 over x times x plus 2. Now it's a standard division of rational expressions problem, and I deal with it exactly as I should by multiplying by the reciprocal, which would give me times x plus 2 over negative x minus 8. Cross that out. And I can then cancel whatever can be canceled. In this case, it's only that x. So that would give me the answer of 2x plus 15 times x plus 2 over 3 times negative x minus 8. And I would probably factor out that leading negative, make it negative 3 times x plus 8. But that's just me. That's it for method 1. Get the numerator to be over one denominator, get the denominator over one denominator, and then treat the complex fraction like a division problem and multiply by the reciprocal. Going back to the PowerPoint, get the numerator over one denominator, get the denominator over one denominator, multiply by the reciprocal. That's the first method. That method works all the time. It will never fail you. Method 2 can be quicker and easier, however, there are rare circumstances where it's going to get you into kind of a messy situation. But that's unusual, that's rare. Normally, method 2 is going to work out fantastic. Let's take a look at method 2. Method 2 is simply multiply top and bottom by common denominator, then simplify. Let's take a look at that. I'm going to go ahead and use the same complex fraction that we used for method 1, just to show that it works with either method. Okay, method 2 says to multiply both the top and the bottom by the common denominator. So the first thing we have to determine is, what is the common denominator? And in this case, we're talking about the common denominator of the entire thing. Any denominator in the complex fraction needs to be part of the common denominator. So this x, this 3, this quantity x plus 2, and that x. Well, the x and x, they're already common, so that's not a concern. That's part of the common denominator. The 3 needs to be part of the common denominator, and the quantity x plus 2 needs to be part of the common denominator. Now, we multiply the top and the bottom by the common denominator. Whatever you do to the bottom, we do to the top. We can remember our little word to help us remember that. Whatever you do to the bottom, you do to the top. The reason it's important to make sure that whatever you do to the bottom, you do to the top is because 3x times the quantity x plus 2 over 3x times the quantity x plus 2 reduces down to be 1. And if we're going to multiply anything by 1, we're going to end up with exactly what we started with. So we're not going to be changing any quantities, any values. All we're going to be changing is the way those values appear, the way they look. So it's okay, and in fact, it's important to make sure that you multiply by the same thing on top and bottom. As long as you do that, you can't screw it up. It may not necessarily be the direction that you want to go, but you're not going to mess it up. You can always fix it later. Whatever you do to the bottom, you do to the top. That's absolutely essential. Okay, so when we do this multiplication, remember that the division bar, the divisor bar there, groups things. So when we multiply into a group, we need to distribute, both on the top and on the bottom. When we distribute the 3x, x plus 2, into the numerator here, and we multiply it by the 5 over x first, those x's will cancel and leave us with 5 times 3 times the quantity x plus 2. Then we have the plus sign from up here. We don't lose that. Then when we multiply the 3x, x plus 2 times the 2 over 3, the 3's will cancel, leaving us with 2x, x plus 2. That takes care of the numerator for now. On the denominator, we'll do the same thing. The 3x, x plus 2 times the 3 over x plus 2. In this case, the x plus 2's will cancel, leaving us with 3 times 3x. We need that minus sign, just like we needed the plus sign from the numerator. And then when we multiply 3x, x plus 2 times 4 over x, the x's will cancel, leaving us with 4 times 3 times x plus 2. Now all we got to do is do all the distribution and clean everything up. When we distribute everything, we get 15x plus 30 plus 2x squared plus 4x over 9x minus 12x minus 24. And combining like terms would give us 2x squared plus 19x plus 30 over negative 3x minus 24. Now that might seem like different than what we had when we used method 1. But it's not. Method 1, everything was in its factored form. Method 2, everything ends up in its multiplied form. They're the same thing, though. If you were to factor everything down, then it would have been 2x plus 15 times x plus 2 over negative 3 times x plus 8, which is what we had when we used method 1. So you get the same results either way. Method 2 generally is going to be a little quicker and easier for you. Method 1 will work all the time. Or you can just become an expert at method 1 since it works all the time. Method 1 could be the only one you ever need or want, and that's fine. Nothing wrong with that. I have an example here. When there's a numerator and two different denominators all with the same variable, that's when you'll probably have to use method 1. And I can show you an example of that real quick. So in this example, you've got 3x over 5 minus 2 over x plus 1 all over 6 over x minus 2 plus 5 over 7. Using method 2, the common denominator would be the 5 times the 7, giving you 35, times x plus 1, times x minus 2. And when you multiply that out and distribute it to the 3x over 5 over here, you're going to end up with an x times an x plus 1 times an x minus 2, which is going to give you an x cubed situation. And unless you're really lucky and get an x cubed sum or difference of cubes, which you know how to factor, you're not going to have any idea how to factor that because there's really no standard way to factor those once you get to that degree of a polynomial. So you're going to be stuck with some really high degree polynomials and not have anything that you can do with them. This is a situation where method 1 is going to be much more useful and get you to the correct answer. If, however, instead of a 5 there we had one of the other denominators with that variable in it, for instance x minus 2, then when we distribute, that x minus 2 is going to cancel, and you're just going to get the 3x times the x plus 1, which is going to be just fine, because then you'll get a squared, and you know how to handle squared equations. You can factor those down and work it from there. So it's not always that method 1 is going to be needed in a situation like that, but it could happen, and like I said, it's rare. It could happen on occasion, so be ready with method 1 if you need it, but method 2 is by far much easier to use than, usually much easier to use than method 1. So I strongly recommend getting good at that. Okay, so just to end it with a summary, method 1, get numerator over one denominator, get the denominator over one denominator, then treat it as a division problem and multiply by the reciprocal. Method 2, multiply top and bottom by the common denominator of the entire complex fraction and then simplify. Thank you very much.